Next up, we've got number 8. Find all solutions on the interval 0 to 2 pi. One more time. Okay, with this one, we've got both a tangent and a cosine function in the same equation. So right away when I see that, I know this is a factoring problem. I can't combine the two of those. I can factor it though. Okay, so I'm going to subtract cosine x from both sides of this equation. That's going to leave me with a tan x cosine x minus cosine x equals 0. Okay, again, I cannot combine the two of these. This is kind of like a xy minus y. Not like terms, I can't put them together. Okay, all I can is pull them apart through factoring. Okay, and the other thing is, remember, factoring, get things set equal to 0 first. Okay, so what can I factor out here? Well, that's a cosine x. I can rewrite this as cosine x times the quantity of tangent x minus 1 equal to 0. And if I ever want to make sure my factoring work, I'll just distribute things back in. Cosine x tangent x gives me the, suppose we can write it tangent x cosine x, which we had up top. Cosine x times negative 1 is just a negative cosine x. Okay, so since it distributes back out, I know I factored things correctly. All right, so now the reason we set both factors equal to 0 and solve, we'll do the sine x equals 0. And then also we have a tangent x equals, minus 1 equals 0. Okay, let's do the cosine x equals 0 first. Now with this one, 0, can't have a triangle with an adjacent side over hypotenuse equal to 0. So I'm going to go to my graph cosine function here. Cosine was our one that started up top and went like so. It runs between 1, negative 1, and I want to know where it's 0. So in other words, I want to know what these x-intercepts are at. Okay, well, cosine has a period length of 2 pi, meaning the halfway point is pi. So this 0 has got to be a 2, and then the other one, half between pi and 2 pi, would be a 3 pi over 2. All right, so those are my two solutions from that factor. If I plug either of those into this factor, it would make it 0, which would make the whole thing 0. I'm going to plan my space better here. All right, for the tangent x minus 1 equals 0, we're going to add 1 to both sides. So I want to know where tangent x is equal to 1. There's a couple ways we can do this. I don't have to do this with a graph, just because that 1 we can think of as 1 over 1, and I can have a triangle with an opposite over adjacent as 1 over 1. That's my 45, 40, 90 right triangle. So I can go to my angles and stay in position for this one. Okay, where is tangent going to be positive? Well, that would be in the first quadrant, where we'd have the opposite one, adjacent one, hypotenuse would be my root 2, because again, we're talking 45, 90. And then I'd also be negative in the third quadrant, like we've been seeing this semester, because here I'd have the negative opposite over the negative adjacent, 2 for my hypotenuse. There's my 45. Okay, so I get the double negative giving me a positive. All right, so we could say our x is equal to 45 degrees, or pi over 4. And also x equals 45 past 180, which would be 225. Or if I'm pi over 4 past pi, it would be a 5 pi over 4. All right, like I said, I could do this one with a graph of the wave. So here's some bonus for you. Remember, our tangent waves looks like so. Running between negative pi over 2 and pi over 2. If I want to know where this graph hits 1 at, well, that's just halfway between 0 and pi over 2. I get a pi over 4. Okay, same pi over 4 I got up here. Now, I'd say it's a little tricky to do this one because the other value I need. Okay, I've got my next 0 at pi. This happens at 3 pi over 2 then. So finding this value where it hits the 1 is a little trickier. I'm not going to go through it, but would be the 5 pi over 4. just average of pi and 3 pi over 2. It'd be the same thing we had here. Solutions down here. So, moral of the story, 4 total solutions, 2 from one factor, 2 from the other. We get a pi over 2, a 3 pi over 2 from the cosine x equals 0, and then the pi over 4 and the 5 pi over 4 from the tangent x minus 1 factor equals 0. There are my 4 solutions. And all solutions on the interval 0 to 2 pi. Okay, so that's going to be the final number of solutions between 0 and 2 pi. Don't need to worry about infinites here.